Turing Complete. Finally. Let's see if I still remember anything. It has been like 2 weeks or something since I've last opened this. And I feel like pointing out that this is not because the game became uninteresting or I got bored or anything. I literally just got sick, had a cough. You can't record voice when you have a cough, can you? So yeah, I'm excited to get back into things. I still might have some residual weirdness in my voice, but that shouldn't be a problem. And yeah, I think overall this is a good place to point out something I've been intending to say, but I think I never did, is the fact that I have honestly been really surprised by how fun this game has been. I'm not sure how good of a review that makes it, but I expected it to be much more of a slog. Much more of a, learning experience where I would have to RTFM and, try to figure out things from reading large amounts of text. But turns out this has been a very interesting game where I was able to just play around with things. So yeah, I kind of feel guilty to the game itself. If I were to not, mention this and create public content about it and make it seem like it was unfun. It's absolutely a very fun game, in case it wasn't clear so far. But yeah, in programming world, 2 weeks of not looking at your program is gonna be huge. I have no idea what I'm up to, but hopefully I can back into things. So yeah, I do remember that last time I added RAM to my leg by making it fat leg. There we are. This is our fat leg. And I had a lot of, what would you call it? Reservations? Doubts about putting RAM in line with other registers, which I think were dispelled by people in the comments. So yeah, people are saying that it's okay. Basically, this is how computers used to work. And I think one thing I was conflating when I was thinking about this in my previous video was the fact that we are not working on a multi-processor architecture. So a RAM operation will necessarily be a blocking operation for my computer, will it not? Right, so even if it takes a million years, it's gonna be weird for me to try to implement it in such a way that while it's happening, I do something else. And actually, well, now that I say it, perhaps I could. Perhaps I could without creating multiple copies of a single core. Perhaps within a core, I could have multiple sub, systems that would be able to do things independently. So yeah, perhaps, but honestly, this is probably fine. And yeah, from what I gather also from the comments, it looks like RAM is indeed at this point in the game, in this level, RAM is indeed immediate. It is the same speed as a regular register. And something I've been thinking is this is gonna be ridiculous, but I kind of want to do it. I think I could put this whole contraption, this whole RAM thing, into a custom component like this and make it tiny. Because, of course, factory components allow you to compress things a lot. So I think I'll start with that as a little bit of practice. before I get into the next actual level. Let's try to build a, what should I call it? A RAMgister. Right, so let's try to copy this. Let's go into the oh. I was already playing around with this, was I? I don't remember. I don't. Okay, is this actually it? I even called it. Wow, I'm repeating myself. Goodness. So this would have been 2 weeks ago, probably, right after I made the video. I honestly didn't remember. I already did it, but okay. So is this what I want actually? I do have everything named, so yeah, I have load, save, address. Yeah, load, save, address, save value, same thing. And then I have my output up top. Yeah. And it'll behave as a register. Wait, but I only have this is not quite right, because I have two. See, I want two outputs, right? In my custom registers, I have two different outputs that are decided based on these ones, 2.1 and 2.2. And I think the custom component I was just looking at, yeah, it doesn't have two outputs. And I want two outputs, I think. I want two outputs, so can I fit it in here? Okay. But wait, then I will also... But I also want to control bits, right? These ones, 2.1 and 2.2. So yeah, my RAM... No, but the load pin is always on in my design. So actually, what's up with my factory? Yeah, in the factory for some reason I decided to include a load pin, which I do not actually want. Instead I will just constantly load, I think. Let's put this always on. I don't know, whatever. Always on. So we're always loading, except now I want two outputs, but I think I also want them gray. Yeah, I want them gray based on 1 and 2. Okay, so let's go back in here. Let's get gray outputs. No. 8-bit switched outputs, so 1, 2. Alright. And then I also want... two inputs, 1-bit inputs. Yep. For 2.1 and 2.2. Let's name them. 2.1 and 2.2. You know, a pipe. And what did I call my outputs? Let's be consistent. Out 1 and out 2. Out 1. No, this is out 2. This is gonna be out 1. Okay. But I don't like how this is asymmetric. This is very asymmetric. So the RAM has this special... What really differentiates my RAMgister from a regular register is the presence of the... yeah, this white line, the RAM address. So... again, I think I want to separate it from everything else so that our interfaces are consistent. So let's just remove it for now, or like move it to wherever. And I think this would then be a proper... yeah. This is a proper setup, and I think a reasonable place to put my address might be here. I'm not a fan. I'm not a fan. Maybe up here. I don't know. Maybe even not just up here. I think this makes the most sense actually. Yeah. Okay. Okay. So I want this guy going here. This is my address. I already have my save value piped. I also want the save bit. Let's make it green, because that's our save. And let's do our in1 and in2 lines in their respective colors. Oh, but I need to... Ooh, this is gonna be a wiring job. Okay, I'll wire this up. Something along these lines. Yeah, I'm trying to cram things as always. It is possible to, you know, space it out, but this is already ridiculous. I could save this. This is my RAMgister. Do I have it saved in the wherever that is? Yeah, I even have it saved. Okay, so I could save this. Then it would be a, you know, single component, and I could condense the entire thing to a single blue square. But I'm not gonna do that. This is already ridiculous enough. I've squished an entire 256 byte? Yeah, 256 byte RAM to a single tiny component. Also, one more thing I should probably point out, although this is not going to be so much me pointing out as me complaining about it. I still don't understand what these wires mean. So there's this darker green, there's this lighter green color, there's also this darker green, which is the same as this, I believe. And in the comments for the previous video, Christopher said that these corresponded to byte or bit width of the wire, and I believe he said that green suggested 64 bits, but clearly that's not the case here. This is clearly not 64 bits. I even have an 8-bit input, right? So this is just 8 bits. I would expect it to be, yep, this color. But for some reason, can I, if I rewire it, will it change color? No, it doesn't. That's curious. That's curious. Maybe this also? Okay, I'm confused by why. So these colors I understand, but oops. Why is, yeah, but this is green, even though data width is set to 8 bits. I assume that basically 64 bits is gonna mean a 64, you know, thick line here. So I could condense it 64 lines into a single one, but when I set 8 bits, I still get this weird green. And it's also showing me a star for some reason, whatever that means. But yeah, I think this should be alright. So yeah, let's go back. Let's remove our large RAM, and let's remove it with replace it with a ridiculously small. Wait, yeah, with the ridiculously small RAMgister. Okay, so this is gonna be our address, right? Oh no, this is gonna be input 2 or direction 2. It's gonna be 1. Wait, why are they're spaced out wrong? Oh well, this should be fine. Now I have save, which I need to pipe from here, right? And then save value I want from my general line. And these guys I connect normally? Like so. Cool. Cool. RAM is tiny now. Okay, let's test this works first. Oh, but I cannot really inspect the insides of my RAM. This might come to bite me. This might come back to bite me. Could I connect these weird probe things? Wire probe, memory probe bit. Okay. Can I? How do I? What can I connect it to? It looks like I can connect it to RAM itself. 0. So this is now displaying 0. I don't know. 0. Which 0 is this? Is this? Oh, this is probably the 0 that's currently active, I think, right? If I pipe some other address, this is probably gonna display the value from the current address. Can I add more probes? What will happen if I add more probes? Well, it doesn't look like there's anything else to connect it to. Well, okay, this might have been a bad idea, but I'm gonna roll with it for now. We're gonna know what the current value in RAM is, and I mean, I do know that my RAM is correct because it's tested, so should be fine. Also, I'm not entirely sure. Maybe I should replace my, what did I call it? I don't remember. I think I came up with a stupidly convoluted but fun sounding name for it. Is this instruction address? No, IR is gonna be, no, I think, see, this is this is me having forgotten some of the things I did. So I think IR is gonna be IAR 6. I think that's the counter, this thing, right? 1, 2, 3, 4, 5, 6, 7. Yeah, cool. Starting from 0. Instruction address register, I think. I'm gonna look it up again. Yeah, that's right. Instruction address instruction address register. I love it. I love it. I think this is a very cool sounding name. Okay. I also think I could improve this setup, or well, customize this setup, make this a custom component. And overall, just generally living my life, I've been walking around and thinking about some of the components, and I think there's a couple of improvements here and there I could make, but I'm gonna leave them for later. And right now, let's go and proceed with actual levels. So I think I intended to finish this branch first, because I'm most interested in the stack. Yes, stack functions. Yeah, this is probably the biggest improvement I can make to my, well, either my architecture or my understanding of how things work. Yeah, these look just like operators. Oh no, delay. No, this looks like my mind is gonna be bent and broken by this. The lab, I don't know. Yeah, let's proceed with the stack. In order to cut spending, it has been decided to change the queuing system at public offices so that fewer people will go. What? That's not. That's. I mean, okay. Depends on how you do it. You can just close the door and no one will ever come. Okay. Instead of first come, first served, we're implementing a last come, first served policy. Okay, cool, stack. Think of it like a stack of numbered slips, where the citizens either put a slip on top, called push, or the bureaucrats take one off the top of the stack, called pop. We want you to implement this new system. Oh. So is the stack a hardware component? Wow, that would be... Each tick, the inputs will either signal push or pop. If it is push, store the value on top of the stack. When it is pop, remove that value from the stack and output it. The output is an enable pin, enable it only on pop. That's no problem, but what is the size of my stack? Also, why do I have 3 inputs? I have push pop. Oh, so this is gonna be push. Yeah, push. This is pop. This is push. And I have my input. Okay. But what's the size requirement? I don't care. This is underspecified. I can't build an arbitrarily large stack. Push or pop. Put the value on top of the stack. Huh. I don't get it. Am I just supposed to wing it? Just put, you know, a bunch of registers down and figure out how many I need, or what? I will need registers, right? I could use RAM. I could use RAM for a huge stack, which would actually not be too bad, I think. I mean, this is an expensive component compared to just a couple of registers, but the expense is justified because I get more registers out of it. And also, this has a built-in addressing system, which is going to be helpful for a stack, right? I could keep a simple address register, right? Like something like this. Well, I would probably use my custom register or something, but... And just increment this or decrement this. Wait, but what happens when I pop from an empty stack? I think pushing to a full stack can overflow just fine. Well, not just fine, but I think that would be the expected behavior for hardware, right? So if we're at the end of this, so I'm imagining push once, put here, push twice, put here, thrice here, then pop, go back, pop, go back. Well, yeah, I guess if we pop again, we just underflow and we go here. But also there's a question with, well, garbage in, garbage out, I guess. If so, the question is, if I have popped something, so let's say I have pushed a 5 into here, right? So let's say there's a 5 here, and then I pop it, right? Hypothetically, I should have well, the 5 basically should stop existing, kind of, you know. In the abstract, I do not want the 5 to exist anymore once it's popped. But in hardware, do I actually go to the trouble of removing the 5, you know, overwriting it with a 0? Or do I just let it sit there? And so I think that would be okay. It would mean very strange behavior given overflow. So for example, imagine that I just pushed 256 random values into here, and then I keep popping indefinitely. Under specification, under strict specification, I would want to be able to pop 256 times, and then I would want to return an error, or, you know, just don't pop anymore. But here, and under my implementation, under my idea, I would keep popping the old values. I would overflow into here, and I would keep popping and popping and popping and popping, and that would be fine. But then if I'm pushing, then I'm fine to overwrite, I think. Okay, I think this makes sense. I'm still not sure if I really need to use a component as huge as RAM, or if just a few registers would do the trick. I do not have a good understanding of how large a stack gets under normal operation, although yeah, I would expect it to be pretty huge in real life applications, but I don't actually know. Okay. So I'll think about this some more, and I'll be back. So one thing that's slightly bothering me is this register here. This is too powerful of a mechanism for a stack. Right? This is an arbitrary address. This is more like a heap. And incrementing and decrementing it sounds like an operation that would be too expensive for what I actually need. Right? So just thinking out loud, if I had not the RAM, but a bunch of registers, I think a stack addressing scheme for them could be something along the lines of how do I propagate? So just again, I'm just thinking out loud here. I could have a wire with ends kind of like so, and somehow I'm not sure how I would preserve state. Maybe with a 1-bit, or I don't actually know, but I feel like having a thing with the interface of not load and save, or oh, actually, yeah, this is probably a good idea, or a better understanding of this, a better way to look at this, is I don't need the operations of load and save on my register, especially not the save. I kind of always want the load, but I don't really want the save. And instead, my interface of the register I want would be increment and decrement. And I feel like that could be an improvement. So where's my register? Where did I implement the register? Memory, little box, counter, no. Saving bytes. Oh, I seem to recall some kind of suggestion on how this could be improved. Yeah, I think I'm not gonna go into this, but I think I might eventually improve this. But so I save bit by bit. Could it somehow be cheaper to only have an increment operation instead of a save operation? Actually, it doesn't look like it would be, right? Because An increment basically is necessarily a load, an add, well, and a plus plus. Plus plus does not need to be a full addition, but it is necessarily a load into plus plus into a save. I can't just somehow magically increment this. In order to increment, I need to load, do something, and then return. So yeah, I think I will just go with the register setup, for which I will have increment and decrement operations. But increment and decrement operations, I am inclined to not using an add for. And I think I already did at some point in some level, I don't remember when exactly, but I think at some point I already implemented a plus plus operator. I didn't save it as a custom component, but yeah, I'll go and try to find it, and I'll be back. Yep, here we are. This is the counter level, interestingly enough, and this is pretty much exactly what I want. A counter is a register that increments itself, except the counter always increments, and I want an increment and a decrement depending on what I'm doing. So I'm thinking I should. So this is going to be my plus plus, right? I don't even care what's happening here. This is going to be my plus plus, I believe. So I'd probably take this, save this as a plus plus gate. I would also want a minus minus, which... Ooh, would that be more difficult? I'm not sure. I would need to... I would need... I'm not sure how a decrement operator would work. I don't remember two's complement. Well, I do, but I can't figure it out immediately off the top of my head. So okay, I'd have this plus plus operator. Would I have it outside my register? I think I would, just because that makes sense for design reasons. And I would also want a minus minus. Okay, so I'll start by making this into a custom component, and then I will proceed to minus minus, I think. I wonder if I could reuse this for both plus plus and minus minus. If I could perhaps have a 1-bit input that would decide if we are plus plus or minus minus, if this is a inc or decrease operation that I'm looking for. But I need to look up, well, I guess let's do it together. Let's do it on video, because I don't expect everyone to remember this that well. I don't think it's reasonable. So how did negation work for numbers? Negation. Negative numbers? Sign negator, I think. Okay, yeah, I negate. Oh! And I plus plus. Huh! Wait a minute. Wait a minute. I understand this is completely different. This is plus plus to a number that is bitwise negated. But it is curious. What's up with the lag? I think it is curious that the plus plus is also present here. Should I perhaps first implement my thing using adders and you know, using wasteful components and then optimize. That might be a better idea, actually. Let's try that first. I think this is gonna be a better idea to start with just a simple wasteful implementation, and then we can consider. So we can optimize. So this is gonna be my plus plus operator, right? I have this input here. This is my input, plus plus output, right? Yeah, result. So this is plus plus, and I also want to have a minus minus, and a minus minus is going to be a plus negative 1. So let's, I think I should have a constant, yeah, 8-bit constant. Switch to sine mode. Negative 1. Okay, cool, can be done. Cool, same thing. So that's plus plus, and this is minus minus. They are inefficient, and I think I can optimize this a lot, but that's the basics of it. And so now, let's see. There's one more thing in which if I push, so it's kind of this is difficult to explain in words, but there's kind of two values in this on the stack, right? I have not two values, two kind of addresses. So let's say I'm sitting here on this guy, and if I need to pop, then I pop this guy. But if I need to push, then I need to first increment and then put my value. However, if I pop, then I first output and then I decrement. And well, I could implement this the other way around. I could be pointing to the next element, and if I push, I put here and don't increment. And if I pop, then first I increment. Well, no, actually, I would still need to increment. Sorry, yeah, and if I pop, I would first... No, I would first decrement my counter, and then I would output the thing. So this is another issue to keep in mind, and... Huh. Okay, so... Well, first of all, regardless of what I do, I will always want to perform the load from my register, and I will want it just directly piped into both of these guys, right? So it doesn't really matter what I'm gonna be doing next. First, I want to know what plus plus is and what minus minus is, because regardless of what I do, I will plus plus or minus minus. And I want to save. I think I also basically always want to save as well. And I just need to decide what I'm saving. Yeah, no, of course not. Let's put these back. Something along these lines. I need to decide. So let's take a mux. Where's my mux? Yep. Let's put a mux here. Something along these lines. What am I doing? I don't know. I don't know what I'm doing. Whatever. I will want to decide using a mux whether I am saving this guy or this guy, right? But the question is... So, okay, if I pop, so this should be fairly simple, right? If I pop, then I want to decrement. What does a mux do? Select 1, 2. Okay, red means 1. So if we're off on the mux, this will mean a plus plus. It's inconvenient that I have two separate inputs, right? I can't push and pop at the same time. Wait, what? Yeah, that's actually a good question. You can't push and pop. Store the value on top of the stack. When it is pop, remove the value. Okay, how on earth did I not ask this question earlier? If I have two of these inputs, then first I can have no operation nop, in which case nothing must happen, which actually makes sense. I think I do want my stack to be able to sit dormant. And with this, actually, this means this setup is already incorrect, because I cannot account for both off, because I will be piping something into my save always. Although, I mean, I can disable this just by... we'll see. But more importantly, and more weirdly, what happens if I both push and pop? This is a stack race. What happens first? Does the push happen first, or does the pop happen first? Or do I get a short circuit, or what's up? Push and pop. This seriously needs to be specified. This is important. Stack, push, pop. Each tick, the input will either signal push or pop. Well, I guess it suggests that it's important, or it's impossible to get both of these on. If it is push, store the value on top of the stack. When it is pop, remove that value from the stack and output it. So do I assume that the situation in which I both pop and push is impossible? But I still kind of need to implement it, even if the implementation is implicit. I don't know. Okay, all right. Well, but then, actually, if I'm either pushing or popping, and this kind of suggests each tick, it will signal either push or pop, right? So this suggests that I also cannot have them both off, which is weird. That's actually really weird. I would want to be able to sit dormant, like I said. But this suggests... Okay, I think this is another bug report, honestly. I don't think this is specified well enough. But if we assume that they can neither be both off nor both on, then I literally don't need one of them. And I can just consider this one a complement of the other. So yeah, if I don't pop, then I push. Which means yes. So I just connect it like so. Let's try this and let's see how it breaks. I would expect it to break. Okay, so this is gonna be the change to what address I am on. And now let's assume let's just design it so that I'm pointing at the latest thing and not at the next address, right? I'm pointing at the latest thing I wrote. So initially I would be pointing at 0. Wait. No, actually, since I am initially pointing at 0, then it's probably more natural to be pointing at the next thing. Yeah. Okay. So then I'm pointing at the next thing, which means if I am pushing... So if this is off, Then I want to use the address that is stored for my access, right? Like so, kind of. This is not correct, of course, but we'll need the mux probably. However, if I am popping, then my address is not what's stored, and instead it's the next address. So it's this one, right? So let's try it this way, real quick. Let's just see what happens. So again, I'm gonna have a mux, something along these lines. So currently I am, yeah, I think I just so this mux is pretty much the same as this one. Well, its control is the same as this guy's, right? Let's keep this constantly on for now. Again, assuming I don't get a both off situation. So this mux is going to be my address, my stack pointer. And now save. Okay, so I also have an input. Where's my save value? Let's do this. I want to save value. Just messily wire it up for now. So this is my saved value, but I also want to make sure, well, I can always load, that's fine. Let's always load. I think this is okay, especially since I have my output switched. Which, by the way, I can just directly pipe like so, whatever, and also like so, also whatever. Right, and the save pin, I only want enabled if I don't pop, which means I push, which means the negation of pop, I think this is my first attempt at a solution. So this is, of course, this is incredibly convoluted and unclean and messy, but let's see if it might work. We're not using the pin. Okay, push to 51 on stack. Well, okay, this is to 51, why not? Let's proceed. Okay, something's wrong, I think. Push to 16 on stack. Something is really wrong. Something's wrong with my increment decrement. Wow, how did we jump all the way there? Okay, something's wrong with my increment decrement, and I think I just... So I push... Yeah, so when I push twice... When I pushed twice... So my address is currently 255. Yeah, I saved... For some reason, after a push... I think I wired the mux wrong. Let's just try lazily negating it without even trying to understand what's happening. Let's do it again. Okay, so now this is more like what I expected to see. Pop to 62, goodness, 216 off the stack. What? Why did I both? Wait a minute. Okay. Push. Oh, okay. So we have already done this. We have already pushed to 51 on the stack. That's great. We have already done this. We have pushed to 16 on the stack. Now we pop to 16 off the stack. Yeah, that's great. I'm slightly confused by where I'm currently pointing. Where's the pointer? So the pointer is 1. It is indeed here. And I actually want it here. But I'm a bit confused by the fact that it never actually got up there. Yep, broken. Okay. So this is weird. Wait a minute. I don't understand what's wrong. I am confused, but I don't see what's wrong. So once I push the 51 and I increase, so my pointer is correct. So my next place to push would be here. Push to 50. What? Push to 51. Push to 16. Cool. And now again, I'm incremented. I am at 2. So the next place I would push would be here. So that is correct. Now I pop, which push 63 I have pushed. Cool. I have pushed. Yeah, and my next location is going to be 3, which is this 0. So that's great. Yeah, so that's working. Okay, why did we break then? Push to 31. Cool, we have pushed and we have incremented. Pop to 31. Okay, we have popped. And again, we are correctly showing what... Do nothing. Well, thanks. Thanks. That was not specified. This explicitly says, take a look here, each tick, the inputs will either signal push or pop. Right? The do nothing or both push and pop is not specified at all. Okay, well, I can fix this, I believe. So I can... Oh, this is a pain. This is a pain though, because I want this switched first of all. I want this switched. And like, oh my goodness. So, again, I'm just, this is far from my final solution, but I'm just suggesting a quick fix. So I want my, oh. No, I don't want that switched actually, sorry. Well, I don't want the OR, I don't want the switch. Instead, I think I just don't save if I'm not doing anything, so it's fine to be doing this. Yeah, and the output is on the... Well, let's not use that guy anymore. Let's do this. I think this is more like it. And what else? Do I need anything else? Do nothing. What else do I need for the do nothing? Do I still always save? I save when I push. Well, I don't need this not. I can just use the push line. Wait, sorry. Wait a minute, this is my push. It's not displaying its meaning anymore for some reason. But yeah, that's my pop and this is my push. This is wired wrong, I think. I only enable this when I pop, so like this. And I only save when I push. So, whatever. Something along these lines. Let's test this now. Cool. Your circuit has been saved to the component factory. No, this is not my final circuit. Far from it. But it has taken me a while already. I'm still worried what's gonna happen to my circuit when I get both a push and a pop. I think I might literally get a short circuit, but I don't get a short circuit. Why? What's happening here? So my max, well, yeah, my max is decided by only one guy. Oh no, yeah, and the... Yeah, I mean, it definitely broke, but... Although maybe it didn't. I'm not sure. I don't think I should be figuring this out on camera. At best I should explain this just separately. Okay. What are my next steps for improving this? Because this is horrible. I do still want custom ++ and -, but these are fairly isolated, so I can implement them separately and that's fine. I feel like I'm doing a lot of duplicate logic with these nots and ons all over the place and multiple muxes. And yeah, this huge contraption. I feel like this could be simplified, but not sure how. Okay, you know what I'm thinking? There's a lot of improvements here. There's a lot of things to do, and they are all fairly interesting, I think. There's the ++, there's the -. The ++ is not a challenge, but the -, I think, is gonna be an interesting one, because adding 1 can be simplified a lot, but adding 255, I wonder if that could also be easy to improve, right? So this would be a ones to an adder thing that can be reduced. But also adding load to this is the register with the always on, which we don't need with this gray pin. I think it would be good to go back to this and implement an optimized register with the no load pin with the always on output, as well as what I mentioned back here. I think there's an improvement possible in this setup. I think it's to do with the green line. I think the guys, these guys have switches inside them based on the green line, and it's actually enough to have one switch or one mux or whatever it was, decoder. So I think that's gonna be a lot of stuff to do, and this video is already long, and I might make improvements to this as well as its components, a first-rate citizen, and put it in a separate video, and a fully official published one. So yeah, that's the plan. I think it'll be fun, and see you next time. Subscribe and hit the bell. Cool game, great game.